Hi, I'm Pat Keeney, an instructional designer with K-12. My assistant and I are here to work with you on a lab that explores mixtures. What do mayonnaise and shaving cream have in common? What about seawater and instant tea? A salad and the loose change in your pockets have a lot in common as well. These diverse groups are types of mixtures. All mixtures are the result of physical changes. Physical changes are different from chemical changes. Unlike chemical changes, physical changes are changes that do not result in new substances. A mixture is made up of two or more substances that are physically but not chemically combined. For example, salad dressing is usually a mixture. Oil and vinegar are tossed together, but each component that makes up the salad dressing does not undergo a chemical reaction with any of the other parts. Also, the parts of a mixture can be separated. It may not be easy to separate the components of a mixture, but they've not reacted chemically to produce a new substance. Mixtures are classified into three different categories: suspensions, solutions, and colloids. Suspensions are mixtures in which particles remain undissolved and will readily settle out of the mixture. Solutions are mixtures in which the particles of the substances are spread evenly throughout. Imagine stirring a small amount of salt into water. The particles will not settle out. Seawater and tea are solutions. A colloid is a mixture of particles too big to dissolve, but small enough to remain suspended in the substance and not settle out. Fog, mayonnaise, and glue are colloids. The important questions to consider in this lab are: how can you tell the difference between suspensions, solutions, and colloids? Further, how would you classify the following mixtures: homogenized milk, salt and water, baking soda and water, and chalk dust and water? Predict if the following mixtures are suspensions, solutions, or colloids: milk, salt and water, baking soda and water, and chalk dust and water. A good hypothesis often takes the form of a prediction. In this case, the lab will help you confirm or adapt your prediction. For example, if we mix salt and water, then the resulting mixture will be what? As we go through the lab, you will learn how to determine this. We prepared for the lab by gathering these materials. We created 4 mixtures containing the following: 300 milliliters of milk, 300 milliliters of water mixed with 15 milliliters of common table salt, 300 milliliters of water mixed with 15 milliliters of baking soda, and 300 milliliters of water mixed with 22.5 milliliters of chalk dust. We labeled them to be sure that we did not get them confused with each other. We allowed each mixture to sit for an hour to see if the solid materials in them settled out. We did this because the best test for a suspension is to observe if the particles in the mixture remain suspended. If the particles settle out, then the mixture is a suspension. We tested for colloids by mixing together small amounts of vinegar with the individual mixtures. This procedure works for certain types of liquid solutions. Note what happened when 15 milliliters of white vinegar were mixed with 15 milliliters of milk. We added vinegar to each mixture. Note the results of each. Can you determine which are colloids? Finally, we tested to determine which mixtures are solutions. Components of suspensions will settle to the bottom of a container. The bottom of the container will get cloudy as the top clears. Solutions will not settle. However, the solid components of the solution will settle out of the solution if you cool it. and go back into solution if you heat it. We put the lids on the containers of the remaining mixtures and then placed the containers in a baking dish full of ice. Which ones were suspensions and which ones were solutions? If a solid material formed in the mixture, then the mixture was a solution. To be certain that the mixture was a solution, we replaced the ice with warm water and then placed the containers in the baking dish. We noted whether the solid material dissolved back into the mixture, which would indicate that it was a solution. You will now be given data to analyze. Think about how other, commonly found mixtures can be classified. Mixtures are all around you, so think about this as you now move on to perform an activity that will aid you in your understanding of classifying mixtures.